All right, let's dive right in. Welcome to The Explainer. Today, we're taking a seriously fascinating look into the future of spatial computing. We're going to pull back the curtain on something incredibly ambitious, Niantic's underlying vision for smart robots. Now, you probably know Niantic from massive global hits like Pokemon Go, right? But what they're building right now, it goes way, way beyond catching virtual creatures on your phone. They're actually out there laying the foundational intelligence for machines that will physically interact with our real world. Which immediately brings us to this massive brain-bending question. How do you teach a robot to actually understand the physical world? I mean, we take our human spatial awareness totally for granted. We intuitively know not to walk smack into a glass door, and we can easily weave through a crowded room. But teaching a machine those invisible rules, it is notoriously difficult. But here's the crazy plot twist. You'd probably think the solution starts in some heavy machinery lab with mechanical legs and clunky sensor rigs, right? Well, actually, scratch that. It starts with something completely unexpected: augmented reality glasses. But before we get into the how, let's look at the why. $552.49 billion. Yep, you heard that right. That is the projected global market size for AI companions by the year 2035. The financial stakes of this tech race are absolutely astronomical. This isn't just some fleeting trend. We're talking about a massive structural shift in how we interact with technology. We're moving toward a reality where our digital interfaces aren't just flat, boring menus on a screen, but personalized, highly intelligent companions that actually exist right alongside us. Asim Ahmed, the head of product marketing over at Niantic Spatial, really hits the nail on the head when describing their ambition. He says their goal is to, quote, transform the traditional map from a static tool into a living companion that makes you love the journey. So they aren't just trying to build a slightly better GPS that plops a little blue dot on a flat street grid. No way. They're trying to create true digital entities that understand your environment, see exactly what you see, and act as a knowledgeable, empathetic guide right there in physical space. Section 1. The Spatial AI Revolution. To test out this massive vision, Niantic Spatial developed what they call Project Jade. And Project Jade features this super cool augmented reality companion affectionately named Dot. Right now, Dot is essentially a digital ghost. It doesn't have a physical, clunky robot body just yet. Instead, it lives entirely inside Snap's new AR spectacles. When you put these glasses on, Dot literally appears in the real world right in front of you. It can guide you across a campus, point out interesting art installations, and actually hold a totally natural conversation with you about what you're both looking at. It's wild. Section 2, meet Project Jade. And Section 3, the companion tech stack. So the really crucial thing to understand here is that this whole experience is the convergence of several technological breakthroughs happening all at once. It's like a giant puzzle coming together. First up, you have the hardware. Snap spectacles acting as the eyes and ears, taking in the environment. Second, there's Niantic's Visual Positioning System, or VPS. That's the spatial mapping software telling the system exactly where it is in the physical world. And third, you have the brain and the voice. Niantic teamed up with Liquid City to give Dot contextual memory, and Hume AI to give it an emotionally intelligent conversational voice. And the crazy part? All of these layers have to trigger simultaneously in mere fractions of a second. Let's zoom in on that second piece of the puzzle for a second, because it's really the secret sauce. A visual positioning system, or VPS, is a technology that localizes a user with centimeter-level accuracy to provide a deep 3D contextual understanding of the real world. This isn't just about knowing your longitude and latitude, folks. VPS actually allows the AI to perceive physical space. It knows the exact angle of a wall, the height of a ceiling, or exactly how far away that park bench is. To put that into perspective, just think about traditional GPS, the everyday tech your phone uses to give you driving directions. It only has an accuracy of about 30 feet, and honestly, it has zero physical context. It doesn't know if you're safely on the sidewalk or standing right in the middle of a public fountain. Niantic's VPS, on the other hand, offers centimeter-level accuracy with 3D semantic understanding. It knows exactly what is around you. This is a profound leap. It's literally the difference between trying to navigate a maze blindfolded based on someone shouting directions at you versus taking the blindfold off and just looking at the maze yourself. Section 4, teaching AI invisible rules. Think about it like this. Dot is a digital graphic, right? It inherently has absolutely no concept of solid matter. So Niantic actually has to algorithmically train Dot to obey the invisible rules of physical space. To pull this off, they're doing things like ingesting 2D floor plans, generating complex pathfinding maps, and running constant computer vision algorithms to provide real-time semantic obstacle avoidance. Seriously, if you're following Dot down a hallway, the software has to mathematically ensure that Dot doesn't accidentally walk straight through a brick wall or float randomly over a restricted area. It has to navigate around crowds and identify open paths exactly like your eye would. But here's the thing. Flawless navigation just isn't enough on its own. The interaction has to feel natural. And that's where Hume AI's empathic voice interface comes into play. You see, sub-second latency and emotionally adaptive responses are exactly what prevent this companion from feeling like one of those awful robotic customer service menus. If Dot is telling you a really exciting story about a piece of art, its voice naturally gets enthusiastic. If it's just casually telling you to turn left at the next corner, it speaks calmly. This kind of emotional intelligence, happening with virtually zero lag, basically tricks our brains into accepting the AI as a genuine real-time companion.
Section 5. From AR to Smart Robots.
Okay, so now I want you to ask yourself this huge question. What actually happens when you give this AR brain a physical body? Because everything Niantic is currently doing with Dot and AR, the centimeter-level spatial mapping, the real-time obstacle avoidance, the conversational AI, the deep understanding of 3D context, all of that forms the absolute perfect operating system for a physical robot. Dot's mind is essentially acting as a real-world training ground for hardware that literally hasn't even been built yet. Industry experts are saying that by the year 2026, any viable AI home robot is going to require 3 absolute, non-negotiable things: autonomous navigation, conversational voice AI, and advanced camera sensor fusion. Now just look at Niantic's current AR solution. For navigation, they've already got their world-class VPS. For voice, they've seamlessly integrated Hume's EV. And for the camera hardware, they're utilizing Snap Spectacles. So Niantic is actively checking off the exact requirements for next-generation robots right now, simply by developing their AR glasses software. It's a brilliant backdoor approach. Now, just a quick note on that last requirement, sensor fusion. The definition here is absolutely key. Sensor fusion is the process of combining data streams from multiple sensors in real time to maintain a consistent world model, even when individual sensors fail. Let's face it, the real world is messy. A camera might get totally blinded by a glare from the sun, or a spatial sensor might struggle in a really dark room. Niantic's software is actively learning how to manage all of this messy, conflicting real-world data across different hardware inputs inside the AR glasses. And that, right there, is exactly the kind of software robustness a physical robot is going to need so it doesn't just trip and fall down your stairs.
Section 6. The Future of Companions.
I absolutely love this specific futuristic anecdote from Azim Ahmed. He envisions a world where a robot could meet you, greet you at the front of the lobby, and take you to the kitchen because it knows where the kitchen is. I mean, it sounds so incredibly simple, right? But to actually achieve that, the robot needs a perfect spatial map of the building, the ability to dodge humans walking through the lobby, and the conversational intelligence to greet you warmly. By putting Dot in AR glasses today, Niantic is solving the exact mathematical and spatial problems required to make this physical robot lobbyist a reality tomorrow. So, what's the big takeaway from all of this? Well, it's pretty simple. The AR spatial mapping of today is literally laying the foundational software brain for the autonomous robots of tomorrow. Niantic's current work with smart glasses and digital characters isn't just about entertainment or gaming anymore. It is a highly sophisticated real-world stress test for the artificial intelligence that will eventually pilot physical machines through our homes, our workplaces, and our cities. It's a real game changer. I'm going to leave you with this final provocative thought to ponder. When a digital mind fully masters the invisible rules of physical space, when it knows every single wall, every path, and every object down to the exact centimeter, what limits are left for where it can go or what it can do? The leap from a helpful AR ghost living in your glasses to a helpful physical robot walking around your living room is much, much smaller than you think. And companies like Niantic, they are bridging that gap right now. Thank you so much for learning with me today on The Explainer. Keep your eyes on the space around you because it's about to get a whole lot smarter.